let's go to clinical trials then.
Okay.
So here. This is back to Scholia, a tool that we will discuss a bit more as well, and that I showed already a little bit. It has not just an overview of the literature, it also has an overview of clinical trials, which also has some fun, let's say, elements. So here you see some trials that start in the year 2100 that are indexed in a database, which basically just reflects that those trials are incorrectly marked up in the source. The source in this case is the clinical trials database maintained by the US government. And so if you check those entries, you notice, oh yeah, it's back there that the date of the trial is incorrectly entered. And then Wikidata mirrors that for the moment, but we're working on mechanisms to actually inform them that their data is not quite and we're also working on mechanisms. So so we see on this clinical trials thing on Scholia what clinical trials are like currently ongoing. Then here we see them sliced by the trial phase they're in. We see the medical conditions that are most popular in those trials, and we have an example trial for those. We see like what are the interventions that are being explored for those medical conditions. So lots of chemical approaches, but sometimes you might see a device there, basic statistics, and so on. And then for each of these things, each of the blue things here is basically clickable. So for example, I can click on any of those here. And then you get a profile for that particular trial. But the page we saw before was an overview about trials in general. And so here this has a title, and here we know 360 participants. It's about adenocarcinoma. It gives us like people who like this trial also liked that trial kind of stats. And then again, each of that is clickable, and from there we can go to, for instance, adenocarcinoma, which is then a topic for which we have also profiles in Wikidata. You see all the trials that are on this particular topic. Well, we don't see all of them. We see how the publications have developed for this particular topic over time, and then we can actually zoom in how this topic is actually treated as a topic in the literature. And that then brings us to one of the more central aspects of this Scholia project, that is profiling the literature on a. So here we could use the adenocarcinoma, but I'm actually tempted to switch over to COVID-19. But yeah, let's just take this adenocarcinoma. And you see these are live queries, so some of those might take some time, some of those might actually not entirely work, we'll see. On the top here, you already see that you get a number of related things. That's similar to most websites that have things that are related to adenocarcinoma here. But here, the mechanism by which these related things are being explored is slightly different. That's just purely on the properties of the Wikidata knowledge graph. So the kind of links that adenocarcinoma has to the rest of the knowledge of the world are similar to the kind of links that connective tissue neoplasm has, or specific developmental disorder. You notice these are all essentially diseases. So this basically means adenocarcinoma is linked to the wider world just the way other diseases are. But some of those are closer and some of those are less close. So once we're on a profile for a particular topic, like adenocarcinoma, we see on top a link to the English Wikipedia article, which might as well also link back to Scholia. Maybe we should check that. I don't know for this particular topic. So this is the English article, and let's just simply check. Scholia does not link back, but in principle it can link back. Let me just briefly show that. So here on the Sigalov, for instance, we have here a little widget that links back to Scholia, and then this would give me the Scholia profile for Zika virus. And the same, you can do the same thing for SARS-CoV-2 or any other things for which the data has been curated. For some topics, the data just hasn't been curated in Wikidata, so it will be less complete. But for those, this usually works. For some reason, probably because we're doing live streaming and recording these kind of things, some of those things seem to take a bit longer than usual. So here you get a profile, but I'll switch back to the adenocarcinoma. And so on top, we have a link to the Wikipedia article. We also have a link to the corresponding Wikidata item, which is the basis for what you see in this profile. But the difference is one that is actually quite fundamental. Here you have one page that has content that is very similar to the Wikipedia concept of having a page that brings things together. But most of the things that you would see on this profile is actually brought together from a number of related pages, which is making use of the nature of linked data, linked open data. And this means linked, well, let's start with open data. Open data is basically data that anyone has access to. And let's keep in mind the machines that I mentioned at the beginning includes automated tools like the queries that you're writing here. They should have access to the data. And then if it's linked, it basically means if I say one of the edits that I made, or the edit I wanted to make about the ravioli kind of thing, the ravioli word is a word for the dish, basically, or so. That's the thing we wanted to say, right? And then when I'm annotating the dish with the word, and then if I look at the profile for the word, then the dish would show up. And if I look at the profile for the word, profile for the dish, then the word would also show up, basically. Even though I made just one edit, because it's all linked data, the things show up in different places, depending on how we ask for them. Which basically means if you have multiple things that are interrelated and you need to create all of that, you create it only once and then you just expose it in multiple fashions. And that's what this profiling tool here does. So in order for this particular paper to show up here, actually recently published works on the topic, August last year, this is probably out of date. This just means that the community hasn't curated this in a while. But in order for this paper to show up here, we first need an entry for the paper in Wikidata. And second, it has to be tagged as being about this particular topic. And so these two steps have to happen on the Wikidata end. And they're not being made because they have happened, then this profile can expose that information. So let's go further. Here we see the publications per year. That's essentially the same graph we already saw on the disease aspect, but with a bit more resolution as to what kinds of publications are this. Then we also, interestingly, we see the earliest published works on the topic. So yeah, sometimes if you're a historian or so, this might be very interesting. For some topics, like religious or historic topics, this actually goes back millennia. So some of the literature indexed in Wikidata really goes back hundreds or sometimes thousands of years, especially like ancient Chinese scripts and stuff. Then you see what are the people that are most active in terms of number of publications on the topic. You see their co-author graph. So the most prominent people here kind of form some networks, and you see how they interact. You see the topics that occur together with your target topic. So we had adenocarcinoma, and so here cholangiocarcinoma, another kind of cancer, just pops up as a related topic. It makes sense. And then immunohistochemistry, yes, because that's one of the mechanisms by which you detect things. Then some of those, basically this table of the topics that co-occur with your target topic, this table can be represented in a different fashion. That's where the data science come in. Data science also, one subfield of data science is visualization of data. So here we have essentially the same data as in that table, but we show it as a graph so that you see, oh yeah, the cholangiocarcinoma, which was first in the table, is actually interlinked with lots of other things. That gives you another idea of how this ecosystem, this knowledge around your target topic is structured. And some of those co-occurring topics actually have a geolocation, so you can plot them on a map. And so, for instance, you have here something in India. Let's see what this is. You can have Indian patients with adenocarcinoma of the lung. Yeah, so that's a sample entry that gives you an idea of the kind of papers that might be published with a relation to India. Then here we have the authors structured in a slightly different fashion, not just how much they've published, but also how often they are cited to and from. This is something that journalists have begun to use in order to identify experts on a given topic, because journalists don't necessarily know much about the topic that they're supposed to report on, because it may be a new topic or just in the news today, and usually not. And so they often need mechanisms by which they can identify an expert that they can then talk to about this particular topic. And this graph just does it for you if you just enter this topic. Then here you get the journals essentially that publish on the topic. So cancer research, yeah, for a cancer, that's not surprising. And then another, they're all cancer journals essentially, with +1 here being a bit of an exception. But that's a very broad journal focus-wise. Citations, here you have one thing that didn't work, but we could, in principle, we would get a list of publications that are cited from papers about adenocarcinoma. And then here we get essentially authors of those papers that are cited from papers about adenocarcinoma. And authors, they're associated with certain organizations. So, and those organizations, they have a map or they have a geolocation, so we can show them on a map. And then some of those authors have received some awards, and so we can show that. And again, the information as to what the or which authors received an award who also published on the topic, this is actually distributed in a graph. So you have the information that, for instance, Harold Wormers here, he received this award. That's one piece of information. And then he authored some papers, that's other pieces of information. And some of those papers are on this particular topic. That's other pieces of information, but they're all linked together in a graph, and so we can combine this in this table. Yeah, so maybe that's good enough for an intro to Scholia. Oh yeah, maybe one thing I should mention, that we're talking about data curation as well. So below this little graph that I showed here, where I was talking about the journalists that use this, we have a little link that says go to the missing page that I was briefly demoing in another context as well. And this means that in order to build a profile of the kind that I just walked you through, you need to have certain kinds of information. And here we have more or less a curation page. We know certain things are missing. So for instance, here there are lots of papers that have this author name string, Timothy M. Polick, that have not been created yet. So probably we need to look at how many people have this name string, maybe just one, maybe several, and then find whether they already have Wikidata entries and then link them. And then these Wikidata entries would show up in graphs like this as the prominent people who are publishing on the topic. And so here we have a really important mechanism that we know some of the things we already don't know. So we know some of our gaps, and that can actually help with curating the information, keeping the data quality high, also exposing problems. Sometimes, for instance, on the maps that I've shown, you would see things like an institution in the middle of the ocean or so, something like this. And this sometimes, like here, you might have an institution in the middle of the ocean. Of course, yeah, there are some small islands here where you actually do have institution, and sometimes they do publish on the topic, but sometimes it just means, oh, someone got like the geolocation wrong. Actually, they missed north and south, and it was actually in Brazil or something like this. And so these profiles, although their primary purpose is to explore the topic of, let's say, adenocarcinoma, they have other purposes, and that is to learn more generally, or to check the data quality, or to engage, to link, for instance, to show this to students who learn about adenocarcinoma, or maybe to some patient who was just diagnosed with this, and things like that.
And we can, of course, see not only about the topic, but also a person. So similar to Google Scholar, but better, right?
Okay, yeah, we can do that.
Yeah,
so,
can we show them just a small example?
Yeah, let's pick one here. So, yeah, this is a space where actually you have lots of corporate interests. So there are commercially available tools that have more or less the same information, but they lock it behind paywalls. And here we have it all based on Wikidata. And so here we have a computational biologist, part of the stability, who also works on epidemiology quite a bit and data sharing, things like that. So here we see her most recent papers. And yeah, for instance, you can click on that. So that allows you to compare different people. So here we get a profile for these different people that have co-authored that particular paper. And then we see a number of papers where these same people have occurred as co-authors again. We see the number of, we see their respective, for each of those authors of that particular paper, we see how they published over time. And so we can actually pinpoint the first paper they have had together, things like that. How many citations they got over time. And here we have an error because the query got too complex. But in principle, if it works, we would see through which papers they're also connected, or which are the other people in this collaboration network. So that was a slight excursion. So below the list of publications, we have a number of publications per year. In principle, we would also have the number of pages, but that's not very well curated. You can look at what's their favorite journals to publish in. Yes, everybody loves Nature and Science. Well, maybe not everybody. We see which people publish with this target person here. And then what are the topics that this person publishes on? So Ebola virus, for instance, malaria, they are quite prominent. Lassa virus, Zika virus, yeah. Then we see some images. Yes, that's actually her. And there are other people, like some of her collaborators, for instance, would show up in this image matrix. Then we see here the matrix that maps the individual papers that Wikidata knows about, that she has co-authored, and then the topics. And so for each of those, I can hover over this, and then here, so this is cerebral malaria, and that is this particular paper. And then from here, I could jump to the profile for that particular paper or for that other topic. Or here we have one that is Lassa fever, Lassa virus. And so here is another one on a Lassa virus. Here's another one on a Lassa virus, right? So we can go vertically just for sticking with one topic, and we can go horizontally to hop between topics, and all of this is mediated by the corresponding papers. So that's another way to browse the work of that particular person. The timeline should normally display. I would just say that's part of our connectivity problem here. Yeah, okay, some locations, yeah. So I think she was born in Iran. Yeah, place of birth, and she now works in the US. Harvard, yeah. And then citation statistic, what's her publication that's most cited? According to Wikidata, here it's important really to know that the data in Wikidata is still incomplete. But yeah, this one, Wikidata knows 2,000 citations here, so which means that this is really well cited already. But maybe one of those others is actually more cited, it's just that this hasn't been curated yet. Then we can plot this over here. We can look at which are the people that are actually citing the work by her. And if she had attended any conferences that Wikidata would know about, then these would be listed here. And also for her, we have such a missing page. So some of the things that we already know we don't know about her. So yeah, for instance, here we have 7 papers that have the string partis si sabete and another one si dot sabete as their author, which is likely her papers. It's just that nobody has curated that on the Wikidata end yet. Some co-author 7 papers that we know have been co-authored by her that also have this string here as another co-author, so we would have someone to check what this Daniel J. Park is and how many of those actually are the ones that are collaborating with partis sabete. And then the same for authors that were citing her. So Li Jin apparently is citing, or someone named Li Jin is citing her work 91 times. And then we can sort this out. Here we have an example. We can sort this out and look at how to create that kind of information. Yeah, I guess that's it for an author profile. And then while we're at this, I would just like to point out we have other kinds of things that we could profile. Maybe just briefly mention that. So we can go for a publisher, printer, also conference series and things like that, or an individual paper. We can also go for a research organization, for instance, a research funder. We can go by location. We could go look at just Israel or so, but the more complex the queries get, the more likely it is actually that they will time out. Or we could go for instance, a conference or something like this, or an individual project, or clinical trials already mentioned. We could go by awards. So let's say Nobel Prize in Physiology, or we have some more specialized topics, like a protein or a gene or a pathway. Hello, this doesn't show right now. Yeah, maybe that's because we're live streaming and then the JavaScript is just overwhelmed. No. Yes. Yeah, so, okay. So here you see a profile for things that are related to the Nobel Prize in Physiology or Medicine. You see the list of most recent recipients with an example paper. You see some of their images, lots of white men. You see the topics they publish about. You see recent publications by them. So there's one from this month here. That's something that even the Nobel Institute doesn't have, like most recent publications by Nobel laureates. It's just a byproduct of linked data curated in Wikidata. Also, we can look at what are the other things or awards that awards of the Nobel Prize for Physiology Medicine received. We can actually use that to predict likely awardees in the next round, because we can look at how often someone has received things that the Nobel laureates also received, and that then gives you a set of decent predictions. And we can look at which locations are associated with some of the with the awardees, and we can filter them. So let's say I just want the place of burial, for instance, and then I get those, right? And yeah, gender distribution, not very even. So that's all information that just comes out of the linked open data nature. Nobody has curated this profile specifically, but these are all independent pieces of information that are curated for whatever reasons. And then through this tool, we can bring these different pieces of information together and then profile things by award. Yeah, so I guess that's it for a brief intro to
Scholia.